Today we'll be reviewing function notation and transformations. So a function is a special type of relation. It is a set of ordered pairs for which every value of x has only one value of y. A relation is just a relationship between two sets of information, and a function is really just a subset of relations. An equation that is a function can be named using function notation. So up until grade 11, mostly we used xy notation. So we would write things as y equals 2x plus 3. But because this is a line, and lines are functions, then we can actually write it as f at x equals 2x plus 3. And we do this because by naming the function, we can differentiate between multiple functions, and it also allows us to tell what we've evaluated the x at. So it gives us more information. So here's an example, f at x equals x squared plus 2x minus 8. Okay, we're using f at x notation because this is a parabola, and parabolas pass the vertical line test, which means they are functions. So if we had f of 5, what that really means is it says go to the function called f, which is this function right here, and everywhere there's an x sub in a 5. So f at 5 would actually equal 5 squared plus 2 times 5 minus 8. And if we worked that out, we would get 25 plus 10 minus 8, 27. So f at 5 is equal to 27. And that really just tells us a point on our function, the point 5, 27. What we're quickly going to review next is the main types of functions that you guys learned in grade 11. So the first type is the quadratic. Okay, the most basic is y equals x squared. That's the parent function. Okay, it has that vertex at 0, 0. It is symmetric about the y-axis, so it has that foldability. It's that line symmetry. And it opens up when the leading coefficient is positive. You also learned about a cubic. So the cubic has that wavy shape to it. It flattens out at the origin there and then goes up again. It is a constantly increasing function, except at 0, 0, it's not actually increasing, but it's also not decreasing. It just flattens out. Next, you learned about exponential functions like y equals 2 to the x. So when the base, so in this case the 2, was greater than 1, it was an increasing function, so as you go from left to right, it is always going up. And then when the base was a fraction between 0 and 1, it would have been a decreasing function, and it actually went the opposite direction. Okay, so it started high and then went low. Things about 2 to the x. It has a y-intercept of 0, 1. It has an asymptote along that x-axis at y equals 0. So it has that horizontal asymptote. Next, you learned about the reciprocal function. So this actually has two different asymptotes. It has the x equals 0 vertical asymptote, and it has y equals 0, the horizontal asymptote along the x-axis. And this is the first function that we learned about that has two completely separate pieces. The next one is the absolute value function. Okay, so that's y equals absolute x. And this one, it's like a straight line, except all the negative numbers, all the negative y values have been flipped up and they become positive, which creates that v. Okay, and then you would have learned about the square root function. That one starts at the point 0, 0, and it's always greater than 0 after that. Okay, so the domain for this one is probably the most interesting thing about it. Domain is x is an element of the reals such that x is greater than or equal to 0. So those were the main functions that you learned about in grade 11. And you would have also learned how to transform these functions. Okay, so here's the general notation for all the different transformations of a function. So if we have a number out front multiplying the function, that's a vertical stretch factor. And it could have stretched or compressed the graph depending on if a is between 0 and 1, it would have compressed, or if a was greater than 1, it would have stretched the function. If a is positive, it doesn't do anything, but if a is negative, there was a reflection in the x-axis. K, which is if we have multiplication within the function, that means that there's a stretch horizontally by a factor of 1 over k. Because everything within the function is sort of opposite to what you think it does. So if it says multiply by k, it's actually a division of k. And that's going to cause either a stretch or compression, and if k is negative, it would cause a reflection in the y-axis. H, it also looks opposite to what it actually is, so if it said -2, then your translation is actually a +2. And if h is positive, it moves to the right. If it's negative, it moves to the left. Okay, so that is a horizontal translation. And then last but not least, if there's something added or subtracted outside the function, then that is a vertical translation. If it's positive, it moves up. If it's negative, it moves down. When applying transformations, we have to apply stretches and reflections first. So that means we're going to deal with those a's and those k's first. Okay. And then last but not least, we would apply any transformation, so left, right, up, down. So it's that SRT. So here's an example. We want to state the domain and range, and we want to graph this. And the first thing we're actually going to do is we are going to write out all the different transformations. So the parent function here, or that base function, it's a square root function. So our base function would be y equals root x. And then if we wanted to write out our transformations, we have to look through the entire equation and figure out what each number is doing to our graph. So we'll start with the stretches. So there's nothing being multiplied out front, but there is this 1/2 inside, and that is going to cause a horizontal stretch by a factor of 2. Remember that k value is always opposite. It looks like it's division by 2, so it would actually be multiplication by 2. Next, we do have this negative. That is a reflection. Okay, and since the negative's on the outside, the y values are becoming negative, so it's a reflection in the x-axis. And last but not least, we have this +3, so that is a vertical translation up 3 units. So I'm going to start by drawing out my base graph, which is my basic square root function. So that's 0, 0, 1, 1, 4, 2, 9, 3. That is my basic square root function, and now I'm going to apply all of these transformations to it. You can apply these two together, number 1 and number 2, or you can apply them separately. So the first transformation that we have there is a horizontal stretch by a factor of 2. So what that means is we're going to take all of the x values that we have and we're going to multiply them by 2. So here the x value is 0. 0 times 2 is 0. Here the x value is 1. 1 times 2 is 2. So the y value is staying the same. We're just multiplying the x value. Here the x value is 4. 4 times 2 is 8. So we would then have an x value of 8. And now I have stretched my graph horizontally, and I've applied that transformation of the half for k. Okay, next we have a reflection in the x-axis. So my graph is just going to become reflected in that x-axis. All that's going to change is the signs of my y value. So 0, 0 once again doesn't change, but positive 1 would become negative 1, and positive 2 would become negative 2. And there I have the reflection applied. So the only thing that's left is this translation up 3, and I'll do that one in red. So I'm just going to take all of my new points in blue, and I'm going to move them up 3 units. And there is my final graph. And there it is. Okay. They are asking for the domain and range as well, so we can look at that red graph. The domain actually hasn't changed. The domain is still going to be x is an element of the real numbers, such that x is greater than or equal to 0. But if we look at the range has been affected by our transformations. It starts at 3, and it only goes down. So y is less than or equal to 3. So there's my domain and my range. So same idea for this one. You guys can pause the video and give it a try if you'd like. The parent function here is the absolute value function. And we can plot that really easily. It's just like a basic line that's been flipped up. So you can draw straight lines on your paper. So there's the base function. So if we look at the transformations here, we do have a vertical stretch. So we're going to have to apply that first. That's what that 3 is. And then we have movement left 2 and down 5. That is a translation. Left 2 and down 5 units. So we're going to deal with these one at a time, just like before. First, our stretch. Since it is a vertical stretch, all we're doing is we're taking each point that we have, we're multiplying that y value by 3. So the origin stays the origin. Here the y value was 1. 1 times 3 is 3. Okay, here the y value is 2. 2 times 3 is 6. Here the y value is 3. 3 times 3 is 9. And we would do the exact same thing on the other side, and it's actually going to be symmetric here. So there is our graph once we've applied our stretch factor. So right now the graph is really y equals 3 absolute x. And the last thing we just have to do is we have to take all these new black points and we have to move them left 2, down 5. Okay, so to the left 2, down 5. So there's the completed graph, and in the bottom here I have written the domain and range. So you guys can get started on the homework.